minutes I see on the stopwatch. So we'll go roughly until about 10 minutes. So then, I want you to imagine that you have a black and white image. So the black and white image consists of pixels, or rather it's represented by pixels, and these pixels are either black or white. Now the representation of this image is going to be in the form of a matrix, which is a two-dimensional array, and that two-dimensional array only has the numbers 0 and 1. 1 represents black, a black pixel, and 0 represents a white pixel. So for example, if you look on your scratch pad here, do you see this two-dimensional array that I pasted?
Yep.
So that might be a sample input that represents the black and white image. Now you are going to be tasked with removing all of the black pixels that are not connected to the border of the image. So when I say connected, I mean two pixels that are, or two or more pixels that are either horizontally or vertically adjacent. And if they are not connected to the border, then you have to remove them. And the reason that the function that we have here is called remove island is because we're going to call these blocks of black pixels that are not connected to the border, we're going to call them islands. And so you want to remove them. So I'll give you the sample output for the input that I gave you here. This would be the sample output here. And it might not look like much here, but I'll show you another thing. This array that I'm about to paste here, this shows all of the islands that we removed. So you can see that between the sample input and the sample output, we removed this island here that had 1, 1. We removed this one that had another single 1. And then we removed this one that had 2 connected ones. And none of these 4 islands here, or sorry, 3 islands rather, there are 3, none of them were connected to the border.
Yep, so, okay, so it's not diagonal too. It's just left, right, up, down.
Exactly. So you might notice that in the sample input, if you scroll back up, there's a 1 in the top left corner. The 1 here in the second row, second column, we removed it, even though it was diagonally connected to the top left corner, because diagonally just doesn't matter.
Right. What's up?
Hi, Jira. We brought you here to...
Okay. I think I get it now. And I know how you're supposed to solve this. I'm supposed to create a graph of all the ones, and then I can see which one is not connected by doing... I guess I could do a depth first search. But I kind of that feels too algorithm heavy. I kind of want to just do a for loop and see if I can do it without creating a graph. / I forgot how to do graphs too. So okay. My initial thing is I want a for loop here. And I think, okay, so the first thing I thought of is all right, I could do one pass to identify all the ones on the edge. I assume the matrix is going to get really, really big, right? That's the idea. And so I can't
yeah.
So this, I'm guessing, needs to be too slow to so this was my first thing. This is the slow version, right? So I take the outer ring and I do the inner ring and then the innermost ring. You know what I mean? So I would do so this one has 3 levels. The outermost level and then 2. But that's going to be too slow. Actually, what would that be? Okay, look.
I would say to start, don't worry about slow? Don't worry about optimizing the solution.
All right. I'm gonna go really slow then. All right, so this is going to be, so I need to store the ones that are on the edge. So I'm gonna call this edges, and I'm trying to decide if I want to make this a dictionary. I think I do, and I think the dictionary, how this is gonna work is I'm gonna store 0, 0, true, 0, 1, false. Actually, I'm trying to decide, yep. So how this is working is this is going to be the rows. This one's going to be the columns.
Okay. And what does true and false represent?
true means it's an edge, false means it's not an edge. So then we're gonna for loop, and actually I could probably do this. Oh, I can actually do this very fast too.
Just, Ben, when you say not an edge, you mean not on the border, or you mean?
Okay, yeah, I see what you're saying. So yes, it's not on the border, and it's not connected. So what I'm starting at the very, so like the very left side, the very right side, the very top, the very bottom. That's what my first loop is going to touch.
Okay.
And I'm going to say whether it's a 1. Okay, so true means it's a 1 and it's an edge. And then I'm gonna do that again on the second ring, and I'm gonna do it again on the inner ring. Okay, this sounds really jank, but this may be really jank. So we're gonna start here though, because I actually don't know why I'm starting here, but we're gonna start here. All right, so for I in matrix, this should be for row. And do I want to enumerate? Let's enumerate. So enumerate should give me the index and then the value. Ooh, now the real question is, does enumerate? I think the first one is the index. Let's do a little test.
Okay.
Run code. Yeah, it failed. Give me output though.
If you click to raw output, you should see it.
Okay, perfect. I did it right. Yeah, so I just want to make sure this was literally the index and this is literally the row, and it did look right.
And just Ben, I don't mean to interrupt you in the middle of your thought process, but when you say you're going to be going through these inner rings, I understand that, but walk me through how, like, what do you do when you're at ring number 2, like the second inner ring? Like, what information from the first ring is going to suddenly be relevant to you?
Well, I know based on the outside ring which ones they're touching.